Let's continue with a short demonstration of shape memory alloy material. What I have in my hand here is a little wire, tiny wire, of titanium nickel, and it's a shape memory alloy material. Before I continue doing anything or saying anything, I have a quiz question for you. This wire right now, is this in the austenitic state, or in the martensitic state, or you don't know? So, the answer is, of course, that we can't know in what state it is, because we have to know whether it is in the hot state or the cold state, and we don't know where the border lies between the hot state and the cold state. The conversion temperature, the martensitic conversion temperature, can lay anywhere between, say, 100 degrees Celsius and minus 100 degrees Celsius. And that depends very strongly on the exact composition of the material. So even a very few percentiles change in nickel or titanium composition will change dramatically already the temperature, conversion temperature. Well, in this particular case, we can do a little test. And so I have put this little wire on a tea bag wire, and I can fill a glass with hot water. And I hope this will be clearly visible on the camera now, but we'll be able to see what happens if I dip this wire into the hot water. What's going to happen is it goes extremely fast. So I hope you can see this. Let's put this a bit closer here. And here we go. So I dip it in, and immediately you see what we get. It goes back to its hot austenitic state, and it is actually a paper clip. So the next question now is, this material right now, as it's laying here, is it in the austenitic state or the martensitic state, or we don't know? The right answer is that it's in the martensitic state. And how do we know that? Well, it's because it's in the cold state now. We know that we had to heat it up above maybe 60-70 degrees to get it to the austenitic phase. But so as long as it was in the water, it's in the austenitic state. So now it's in austenitic state. Now I take it out and I let it cool down. Now it's for sure below 50 degrees again. Now it's in the martensitic state. Importantly, we see here that the phase change from austenite to martensite does not necessarily change the shape of the material. So if I need to deform the material, I will need to deform it by an external force. For example, I can pull this open again. So it's still in the martensitic phase. And it's only going back now. So I need this external force in the martensitic state to deform it before I can go back to its and have actually the mechanical work done when it goes back to the austenitic phase.